Good morning or good afternoon, depending where you are on the continent. I'd like to welcome everybody and thank you for choosing to spend some time with us today, taking it out of your busy workday. And our objective today is pretty simple. We really are just looking to share some knowledge with respect to safety around lithium secondary chemistries and perhaps make your workplace a little safer, or at least make people aware of what the potential risks are. My name is Ron Workin. I'm the regional manager for Excell in the Greater Toronto area, located in the Mississauga office. And the gray hair that you're witnessing is entirely due to some 20 plus years in the industrial battery business. I make no apologies for it, though. It's been fun. I'll be joined a little later on by Mike McWillie, who is our Director of Engineering. Mike will cover some of the technical information that we'd like to get out to you, particularly with respect to thermal runaway and the role of the protection circuit or safety circuits when it comes to lithium-ion cells and lithium-ion battery packs. And then Craig Semple, who is our regional manager in our Calgary location, will wrap things up talking about disposing of cells or packs that have run wild, as well as the shipping regulations that are around lithium-ion cells. Just a little bit on housekeeping. We are recording the session today so that we have it for later use. We have it available. Also, on your screen, I believe you'll see a little Q&A button. Please feel free as we go along to type your questions in there, and then at the end, we'll take some time to answer your questions. So today we're going to focus on lithium-ion, lithium polymer, and lithium iron phosphate battery safety. We're going to talk around handling and all of the good things that go into that. And of course, to keep the legal beagles happy, we have inserted a disclaimer, and I'll give you a few seconds to read through that if you'd like. But it's part and parcel of what needs to be posted anytime you talk about safety or health. So who is Excell Battery? Well, Excell Battery has been providing OEM industrial and medical battery packs for some 35 years. Our goals really are to provide safe, reliable battery packs, working first time out of the box, if you like. And those goals haven't changed since for some 30 odd years. We've been around for 30 plus years. So what are we going to be covering? Well, we're going to start, obviously, as I mentioned earlier, with rechargeable secondary lithium chemistries. We're going to talk about safe procedures for receiving those products, for handling, for storing them, and as well for use on the production floor. We're going to talk about how to identify incidents and what the safety procedures should be for those incidents. As well, Mike will cover some of the design and application safety and the best practices in that area. And then, as I mentioned, Craig will follow up with the shipping regulations and requirements. So we've all heard the stories. Hopefully none of you have had an opportunity to witness them close up, but lithium-ion in particular has made the news on occasion in a rather uncomplimentary manner. At Excell, we call those URDs, or unscheduled rapid disassembly events. And we do everything in our power to make sure that that doesn't happen. The root causes really on this can vary. Often they lead back to either quality cells, poor design, poor manufacturing, and of course, that variable that we all have to deal with is known as end user abuse. So how safe are lithium-ion and lithium secondary rechargeable batteries? Well, I've been at this for about 20 years, and I'm still here. So I'd say they're reasonably safe. They're actually very inherently safe when they're manufactured correctly. And under normal operating conditions, as you can see, there is no metallic lithium present, unless the cell or the battery pack is exposed to some form of abuse. So abuse, one of the places it often happens is in packaging, handling, and shipping. And that is a very important area in order to ensure that we all remain safe. This is a high energy density chemistry, so there are potential hazards when things go wrong. So there are several key safety measures. We're going to go through each one of those, and we'll talk about some physical abuse, mechanical abuse, or thermal abuse, which are generally the reasons why you have an event. So safety starts at incoming and receiving. And one of the things that we do very well here at Excell is when we receive these products, we make sure that we inspect the outer cartons for any kind of structural damage. And we make sure that when we do open a carton, we use an instrumented method that ensures that you're not going to damage the contents. Lithium-ion cells in particular have a very thin insulator around the can. And if you cut through that with a sharp knife, you might get unexpected results later on. So inspect the cells, packs, make sure they're electrically isolated from any adjacent cells or packs. And don't drop the cells, don't drop the boxes, or place them anywhere close to a heat source. Heat sources are not your friend when you're dealing with rechargeable lithium chemistries. In the warehouse, wherever possible, store them in the original packaging. And then make sure they're stored on some secure shelving, and an ambient temperature environment is the best storage for lithium-ion. If you do have to remove them from the original packaging, once again, ensure the cells and packs are electrically isolated, meaning there's no chance for one to short against another. And very important, if cells and packs are dropped or mechanically will be used in any manner, they need to be visually inspected. Damaged cells and packs should never be placed in service. And Craig will talk a little bit about how to package and deal with them and send them to recycling. So a little bit of a quiz. Okay, we have some nice results on that one, so we're going to move along. So once we get to the production floor, there are some inherent risks here that everybody should safeguard against. If you're taking them from your warehouse to a workstation, they should be transported on a mobile cart, securely fastened and in their original packaging. And mobile cart's a good idea because if you're dealing with packs that have bare wires, somebody happens to put it up against a piece of clothing while they're carrying them, the result is not real good. And again, the production personnel, and this is some training that you should make sure happens on your floor. They should handle them in a safe manner and guard against any opportunity for a short circuit. Production personnel are also responsible to visually check the packs and or cells. Again, what you're looking for is any kind of physical damage, like a dented cell, some wire insulation missing, connector damage. Any of that should be noted, and the pack should not be used. So I think the most important part of this one is the message that says, do not disassemble, overheat, incinerate, or expose contents to water. And most important statement there would be use only with an approved lithium-ion charging system. This is a message that goes on every pack label for a lithium-ion or lithium rechargeable pack that leaves Excell. So if you have a failure of the cell can crimp or any other breach of the casing, there's a high possibility electrolyte is going to vent. It's corrosive, and it's an inhalation hazard. And any kind of corrosion can be just as damaging as an explosion. So some ways here to identify perhaps when you're going to have an incident. And again, I would suggest training on the production floor on this. Any smoke coming from the pack, and of course, you're going to recognize if you have a fire as the pack has exploded. I think both of those are probably fairly easy to recognize. The main causes and of what causes a secondary cell event, obviously temperature reading being exceeded is a big one. A short circuit, excessive charging current, going back to using an appropriate charger, any kind of extreme over discharge, and then vibration shock and the usual crushing, puncturing, or damaging the cell mechanically in any way. So when you have one of these events, and let's hope that you never do, I think the note in bold letters here is certainly the most important thing that you can do right out of the gate, and that's evacuate personnel. We certainly have, through our training here, that is our first step if and whenever we have an event. And suggestion would be that you make sure that you're somehow tracking those who are on your production floor so that when you do evacuate and go to a safe spot outside the building, you can make sure that you have everyone present. If you can, ventilate the area until the odor is no longer present. You're going to want to, before you attempt that, you are going to want to put on some protective equipment, a respirator, gloves, safety glasses are all requirements. So we have an area in our building that contains all of this equipment for just such an event. Again, I'm not sure that I can stress enough that get your personnel out of the building. Really, the fumes here are very toxic and can very quickly cause health issues. Wait for the battery to cool completely. If you have a thermal temperature device that you can check the battery from a distance, please use it. We certainly have one here that we use in such events. And keep your personnel away during that time. Again, the battery is still venting and you're still going to have fumes. We also have in our building and all the other buildings a container that is explosion proof. So if you can do it and do it immediately, then put the battery in that container and make sure that it has a secure lid. So if you do have an incident where you have someone has contact with the electrolyte, if it's with the eyes, get some medical attention right away. If fumes are inhaled, breathing problems, respiratory problems are present, again, that's medical attention. Contact with the skin in small areas you can treat by washing with soap and water, but I would highly suggest that you monitor that person very closely to make sure that they're not suffering any after effects and to make sure that you have actually contained the contact. And of course, if a battery explodes, it's shrapnel that is probably the most dangerous part of that. And then it's going to be followed, obviously, by a toxic and corrosive atmosphere. So another little quiz here. So the correct answer to that one certainly is, as I stressed throughout the presentation, is get your people, your personnel out of the building and away from the event, really due to the toxicity of the fumes. I'm going to turn it over now to Mike McWillie, who's our Director of Engineering, and Mike will take you through some of the technical aspects